This is the second example of graphing a logarithmic function. So we are given g of x equals -2 plus log base 4 of x plus 3. We want to plot at least 2 points and also draw the asymptote. And remember, logarithms have a vertical asymptote and exponential functions have a horizontal asymptote. So because we have a logarithm here, we're going to have a vertical asymptote. And we saw in the last video that the vertical asymptote occurs when the argument is equal to 0. And the argument is what is plugged in to your logarithmic function. So the vertical asymptote occurs when the argument is 0. So I'm going to go ahead and say x plus 3 equals 0. And so that gives me a vertical asymptote at x equals -3. I have to solve for the x there. So I'm going to go ahead and put x equals -3. And I want to go ahead and plot that first, just so I know that my graph is not going to go there. So I'm going to grab my line tool, and I want it to be a dotted line because it's not part of my graph, it's just the asymptote. And then I'll go ahead and make my vertical line right at x equals -3. Okay, so there's my vertical asymptote. I know my graph will not cross that line. And now I want to go ahead and get some points on my graph. So we saw in the last video that the easiest way to get points on your graph is to change your equation to exponential form. So I'm going to go ahead and write my equation as y equals -2 plus log base 4 of x plus 3. And I want to change that to exponential form. So first I'll add the 2 to both sides. So I get y plus 2 equals log base 4 of x plus 3. And I'll go ahead and change that to exponential form. So that becomes 4 to the y plus 2. I'm going to put y plus 2 in parentheses, equals x plus 3. And I'll just take it one step further, and I'll say 4 to the y plus 2 in parentheses. That whole expression minus 3 is equal to x. So now I've put my equation in a form where I can pick y values and actually figure out what x is. So for example, let me pick the y value that's going to make the exponent equal 0. So for example, let y equal -2. If I do that, then x is going to equal 4 to the -2 plus 2 minus 3. And that's really just 4 to the 0 minus 3, which would give me 1 minus 3 or a -2. And remember, that's my x value, so my ordered pair is going to be -2, and y was -2, so -2, -2. So that will be my first point that I plot. And then for a second point, let me go ahead and pick a y value that will make my exponent equal 1. So for example, let y equal -1. And I'm picking the -1 because -1 plus 2 gives me an exponent of 1. So I get x equals 4 to the -1 plus 2 minus 3. -1 plus 2 is just a 1. So 4 to the first power is 4 minus 3 would give me a 1. So when x is 1, remember this is my x value, y is -1. So I'll have 1, -1. And because I'm plotting this by hand, it won't hurt me to get a third point to try to get more accuracy. So I might go ahead and pick a third y value. So for example, let y equal, let's say y equals 0. Then I'm going to get x equals 4 squared minus 3. So that will give me 16 minus 3, which is 13. So a third point would be 13, 0, but that's actually off my grid. And so what that tells me is that my logarithm has to be pretty flat here, because I know that I'm not going to get to the x-axis until x equals 13. So I'll go ahead and connect these points. I have my vertical asymptote here, and then a pretty flat logarithm here. All right, so there's the graph of my logarithmic function. Remember, the domain is all possible x values. And if you look at the graph, you can see that x has to be greater than -3. So I'll have -3 in parentheses. And then x can be any number larger than that. So -3 to infinity. And then the range is the y values. Y can be any number actually. So -infinity to +infinity. And you can visually see that on the graph. The domain or x values cannot be -3 or below. So as a summary, what you want to do is first find the vertical asymptote by taking the expression that's plugged into the logarithm and setting it equal to 0. Then you change your logarithmic function to an exponential function or exponential equation, pick values for y, and then use those to get the corresponding x values in order to get your ordered pairs.